Hey grade 9s! You've probably figured out by now that a gradient describes how flat or how steep a graph is, and they are super duper important, okay? I mean, like, not just for straight lines, but next year they're going to come into a section called analytical geometry, and they're going to make an appearance in science too. And then in grade 12, when you're doing calculus, well, calculus is all about gradients. The good news is that gradients are not that tricky to understand. So in this video, I'm going to show you exactly what a gradient is. I'm going to show you the formula for a gradient that you have to know and understand. And I'm going to show you 3 ways that you can find the gradient. Let's get going. To explain the gradient, we're going to just quickly tell a little story. Just stick with me, I'm going somewhere good with this, and it's an important concept to understand. So let's say we are in a car, we're on a holiday. We're driving from Joburg to Cape Town, right? Here's Joburg, there's Cape Town. And we go down the escarpment, whee! And then we are driving in the Free State. The Free State is so flat, they say you can see 2 weeks into the future. And then we go up the mountains in the Cape. And then maybe there's a little bit of a flat slope down to Cape Town. Okay, so we've got a bunch of straight lines. Just imagine I drew straight. I can't draw very straight on the computer. So if I want to look at the gradient of sections of this journey, I can maybe say this part from Joburg down to the Free State, it's pretty steep, right? And this part here from the mountains down to Cape Town, that's pretty shallow. When we talk about what a gradient is actually just the amount of distance we go up or down relative to the amount of distance we go sideways. So let's look at this practically. Let's say we take this section from Joburg down to the Free State. You'll see that the change in x is 1, 2, 3, 4 blocks. So we write change in x as triangle x. That is just the capital letter for Greek letter for delta. Okay, it means we can say delta x, but we'll usually read that as change in x. Okay, so from now on, if you see a triangle in maths, it usually means change in x or change in whatever. So delta x is going to be 4 blocks. You agree? It's been 4 blocks. There's 4 blocks change here. What's my delta y? What's my change in y for this section of the journey? It is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 blocks. Okay, so I can say that if we put these two relative to each other, there's a much bigger change in y relative to the change in x because it's very steep. So there's much more of a change vertically than there is horizontally. For those of you who get confused, just learn these words, please. So vertical is up or down, and horizontal sideways. So we can actually say that the gradient is all about my change in y relative to my change in x. So we can say it's delta y over delta x. I'm going to explain with the shallow gradient here. Here this bit with going down to Cape Town from the mountains, you've got change in y over here with 2 blocks, right? So my delta y is 2. We're going to count this nicely just now. I'm not working with negatives and positives right now. 1, 2, 3, 4, 5. Okay, and my delta x is 5 blocks, right? So do you see I've actually got a change of 2 blocks for my vertical, and I've got a change of 5 blocks for my horizontal. So we're going much further sideways than we're going up or down. So relative, if you speak about the vertical or the y versus the horizontal, the x, then my x is way more for the shallow gradient. Do you see? And that's what gradients is all about. Gradient, my m value, is literally about just comparing my y to my x. So what we do is we take the change in the y and we divide it by the change in the x. If my slope is steep, I'm going to have a really big number over here at the top, and we're going to divide it by a really small number at the bottom. And that's going to give me a big gradient, right? A really steep gradient. If my gradient is really shallow and it's really a really small gradient, then I'm going to have very little change in y. So I'm going to have a small amount of change in y at the top, and I'm going to have a really big amount of change relative to the y at the bottom. Okay, so it's not really about how many blocks. I can have a change in y of 1,000, and I can have a change in x of 1,000, and that's going to give me a gradient of 1 because it's been 1,000 divided by 1,000. So that's going to be give me the same gradient as something where my change in y is 3 and my change in x is 3. It's going to end up giving me exactly the same gradient because I'm moving up as much as I'm moving sideways in both scenarios. So gradient isn't so much about how far you're moving up and down or horizontally as about how much you're moving relative to each other, up or down, sideways. If this is not making sense to you, don't break your head about it. It's great if you do understand it. But otherwise, just memorize this formula. This formula is the one you really want to understand and know for grade 9. Our first method to try and work out the gradient is called a visual method, and we call it rise over run. Rise over run is literally about counting how many blocks of y and how many blocks of x there is in a section of the graph. So for this gradient going down from Joburg to the Free State, we would literally count the number of blocks and then work out our gradient based on that. So let's see how that looks. So m is my change in y over my change in x. How much is my change in y? Let's count it. We start over here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. But we are going down, right? And because the y is positive at the top and negative at the bottom, when we're going down, we actually say it's going in a negative direction. So we say it's negative 9 blocks because we're going down. Then for my x, I start over here where I stopped with a y, and I go towards the point where my line that I'm busy calculating stops. So I'm going to count 1, 2, 3, 4. And it's going to be, because it's moving to the right and the x-axis goes from negative to positive, I'm going to say that's a positive 4. So my gradient for that part of my journey would be minus 9 over 4. Let's do the section going to Cape Town. My journey to Cape Town is literally 1, 2, and it's going down, right? So it's minus 2 for y. I want you to actually always draw this. So it's minus 2. And then we're going to the right. So it's 1, 2, 3, 4, 5. 5 blocks. So my gradient is minus 2 over 5. Let's just take a different slope. Let's take this line. So my y is 6 down. And it is 2. But now it's going that way, so it's negative for x, and that would mean my m is 3. Does that make sense? I hope it does. So that's how you do rise over run. I just want to quickly tell you about 2 things. With rise over run, I can always use the part below the triangle. You see, we kind of draw a right angle triangle. We can do that below the line, or we can do it above the line. So I could have done this section as well. I could have counted here, but then I'm just going to do it differently. So look, nobody's preventing you from counting x first, but I suggest, just so you don't get confused, count y first always, okay? Just makes it easier. M is delta y over delta x. My delta y is going to be 9 blocks up. I already counted it, so I'm not going to, so now it's plus because I'm going up. I'm counting from the bottom upwards, okay? And then I stop at the corner, and then from the corner I have to count to the other side. So that's 4, but now I'm moving in the negative direction. It's minus 4. It's still going to give me minus 9 over 4. And that's exactly the same as we got before. But you'll see that the sign swapped around just because we're working on the other side of the line. Okay, the most important thing with doing rise over run is I kind of always say don't pick up your pen. What I mean by that is if you're doing Y, you have to start on the one end of the line and go up or down wherever you're going. So in this case, we're going up. Now, I can't do that with a Y and then start on the other end of the line and go towards the corner. I can't do that. I can't pick up my pen, so to speak, okay? I have to continue from the corner and go towards the end of the line for X. Else you're going to get the wrong sign. Because if I go from the corner to the other end, I'm going in that direction. But if I came from the end of the line to the corner, then I would be going in that direction. My X's sign would be wrong. So kind of don't pick up your pen. Just move from the one side of the line, move up or down, and then from the corner, take your pen and go to the other one. And you can't really go wrong. You do Y, you do X, you use the right sign, and you simplify and get your gradient. I suggest that you practice this a little bit just to get used to it. It takes some adjustment, but you'll get the hang of it pretty quickly. So let's quickly do our second method to find the gradient. And this is, in my opinion, the most important one. I call it the main gradient formula. This is just an adaptation of what we've already learned. M is delta y over delta x, but we can expand that a little bit. Let's say we call this point 1 and we call this point 2. Then delta y, the change in x, is basically the y of the first value minus the y value of the second point. And your change in your x is actually the x value of your first point minus the x value of your second point. And there we have an incredibly important formula. So you're basically literally, you don't even need the graph. I'm going to show you one example of using this formula with the graph, and then one example using it without the graph. Now we sub this in. So I'm just going to color my point 1. So my y value of point 1 is 5, and I literally just substitute it in there. My y value of point 2 is minus 4. Now be very careful with this bracket, because if you don't put the bracket there, you're going to have two minuses next to each other, which you're not supposed to have. And you know by now that if you've got that minus outside the bracket, you need to multiply that in. It's going to become a positive. So if you don't have the bracket, you're going to mess up a little bit. Please substitute correctly. Don't be lazy. Just use your brackets. Your x value for point 1 is going to be minus 7. And your x value for point 2 is going to be minus 3. Once again, we've got that bracket situation going on there. 5 minus 4, so that minus times a minus is a plus. That becomes 9. Does that look familiar? And that's the same as last time. And then minus 7 minus 3, so that's a plus. So minus 7 plus 3 is minus 4. And voila, we've got the gradient. So you can see that we can actually take a line, and I can give you 2 points, and you don't even need to have a Cartesian plane, and you can work it out with this formula. Now, the reason why this is so important is because that is what's going to happen for the rest of basically high school. They're going to give you points, and often you're going to have to work out a gradient without any line in sight. They can tell you we've got a point A, and it is 3 minus 6, and we've got a point B. What is the gradient? Then I'm going to say M of line A, B is equal to y of A minus y of B. You see, this is y1, y2. I just switched it to make it A and B because it's just easier that way. And then xa, happiness. Y of A is over there. Y of B is over there. X of A is over here. And minus 6 minus 5 is minus 11, and 3 minus 2, it's plus, so that's going to be 5. And that's my gradient. Horrible numbers I'm working with, but you get the point. I just want you to always be careful. You can't swap this around. So you can't substitute it like this. They are not interchangeable, okay? So you can't have like the second point's x down there first, and then do the second point there. That's not going to work. You might ask me, how do I know which point I need to make first and which point I need to make second? It doesn't matter. So I could put the second point first and put the first point second. But what's important then is I have to make my x also my second point's x and my first point's x down there. So as long as you are consistent with keeping the coordinates from the same point in the same position, then you are okay. But you can't mix them up like this. No. So I want to show you a third way to find the gradient. We do this using substitution into the equation y is equal to mx plus c. So let me show you how that works. Say somebody gives me 2 points on the line. One of them is the y-intercept, and then they tell me there's one other point on the line. So now they want to know what is the gradient. Now, I would actually just advise with that, you've got 2 points. There's actually no reason you can't use the gradient formula I just showed you. But I just want to show you how I find this when I'm working with the equation. So I can say, okay, my y-intercept I know is c. So I can go ahead and substitute 5 in there. So I've got 5 there, but now I haven't used the other point yet. So I can say I've got an x here and a y there. So I can actually use that to substitute into the equation. So I can make m my unknown variable that I'm solving for and just take that point and chuck it into the equation. So my y value for that point is 3. Now remember, I have another video on this, but your y and your x's always need to go together. You can't take the y coordinate from one point and the x coordinate from the other point and substitute them into the equation at the same time. Can't do that, but I can do this. I can say 3, and then its friend, the x, is going to be 2, and that leaves me with one unknown to solve for. M is equal to -1. Happiness? So I can do that to also find my gradient, and I can do it the other way. I can substitute. So see, over here I used method 2, and over here I used method 3, and both of them gave me exactly, where did my -1 go? It's a minus, I'm so sorry. Both of them gave me exactly the same value. So you can use whichever. I would usually go for this because you're going to have to use this a lot anyway, but it's important when you're finding the equation later to be able to do this third method. So I just did that in the meanwhile. So just to recap, my first method of finding the gradient is a visual method called rise over run. My second method uses the formula m is equal to y1 minus y2 over x1 minus x2. My third method uses substitution into y equals mx plus c, and these two methods are what we call algebraic, meaning that we don't need a graph. We can literally just work with numbers and formulas, and we can find the gradient using that. All of this might feel like a little bit of information overload to you, so I suggest that you go back and you catch some summaries from this lesson. So you need to make a list of the 3 ways to find a gradient, and you need to make sure you include those formulas I showed you. I often find when somebody's struggling with this section, then they haven't taken the moment to memorize the work. It's not a lot of theory, but when you know your theory, doing the sums is going to be 1,000 times easier, trust me. That's it. Thank you very much for watching. If you like this video, please subscribe to my channel so that I can make more videos like this one and you can find them more easily.